we doing here?
Recursive formula.
We do need a recursive formula.
A-N equals A and open parentheses point. Point.
So close.
And then that's the new car. Before it depreciates after you drive it off the lot.
Is it a much better?
Huh? Why do you do 100 minus 18? Because depreciating means it's going down. Very nice. So if it's going down 18%, you have to know your equation isn't that. Your equation is how much value it's maintaining. Right? So you're going to learn today, you're either going to do 100 minus if it's going down, or if it's going up, you're going to do 100 plus. Exactly. Okay? So, what is 100 minus 18? 18 coming right here. 82.
Okay, so point
So do I put that? Yes, very good. You put it into a decimal, you do 0.82. 82%. Percents are not actual numbers, they're kind of like a different thing. You need to convert into a number. Okay, they're a ratio. Alright, and what is my a sub 0? Baboon.
21.
Baboon. So does that make sense? Not too bad? Not too shabby. Alright, so this is the recursive formula. Remember how we did recursive and then we did explicit?
Yeah.
Same deal, except when we're doing explicit, we're going to turn it into functions. All that means is we're going to use x instead of n. That's all that means. Okay? So we're going to use f of x because it's a function. They're all the same thing. And we want to define the variables. Okay? The beautiful, does anybody know from last night?
A parentheses and then N.
What does A stand for, though?
Something.
You check it out.
You got me there. R.
Or you just one half.
If you want a formula, that's your formula.
Okay.
So your initial value, what you're starting with. Multiplying it by how much it's changing each time. And then you raise it up to the x power. Not too bad? Oh, very good.
Anything ever go where the X is?
When we solve for something, it will. So check this out. What does x stand for?
N.
X is n. What is it in context of the problem? What two things are we comparing? Years. Years and cost. So cost is your f of x or your a sub n. So if I had asked you the cost of the car in 74 years, what would you do? Put 74 in for x, right? Does that make sense? Cool. I'm so glad. Cool? Alright, make sure you got it down. We'll do a bunch of practice. It'll be thebomb.com at it.
That's where it works at.
I'm not really surprised by that.
Check it out.
I think recording it, that's website. Can I click? Do you need a second to copy something? Alright, so our lovely equation we're dealing with 21000 times point, was it 0.82? Yeah. To the x. Go back. Go back. Alright, so how much is the car worth in 5 years? What are we looking for? What are we doing? We're doing a humper home? Who went where? 5 in for x, because years is your x value. So f of 5. This is the reason you wanted to have graphing calculators today. I don't think anybody wants to find out what 0.82 is to the fifth by hand. You're welcome to.
Oh, no.
I'm sure it would be a super time. Okay.
7,785.
Alright, and what does this mean?
After 5 years, the car is appreciated and starts new value here and now. Which is
Thank you.
Okay. After 5 years, the car is worth $7,785.54 according to Kelly. You know about Kelly? Kelly Blue Book. Unless you've gotten into accidents and dings and all sorts of things. Right. Yeah. Okay. Well, no, for you.
Why didn't you like divide it by 5? Where the F and you just leave that 5 alone? Yeah.
It is to the fifth power. So if you're putting this into your calculator,
It's like the
hmm?
Yeah, it is.
Wait, what?
We're talking about that F and then 5. Yeah, that.
So, remember, this is just a function notation. This is just y. And the beauty of function notation is you're saying which number you're plugging in. Just like when we did a sub n, this would be a sub 5. So it's just keeping track of which number you're substituting in for x. Yep. It's just kind of a goofy notation thing. Good question. It does look like multiply. I know. That sucks. When is the car worth a third of its value? What is a third of its value? What was its initial value?
7,000. It's the service value is 7,000.
Yeah. Divide this by 3. 21 divided by 3 is 7, and we tack on 3 zeros there. So when is it going to be worth $7,000? What do you need to do?
Add some years. Instead of raising the power, you square it.
No, good guess. I like that.
Take that point here.
Remove that 5 and make it a 3 or a 2 or a 4.
Something like that.
Oh,
Right?
1/3? That's what we did last time.
Hmm?
You said it equal to?
Oh, it is a fraction. Yeah. Wait, no, it isn't 1/3. What? Because it made it negative.
Is 7,000 an x value or a y value? Or f of x?
That's a Y.
It's a y, right?
Yeah.
So basically we want to know 7,000, right?
Okay.
Question for you though. Do you know how to get the x out of the exponent?
Yeah.
Yeah.
No.
You take notes on it yesterday? Alright, so it's
We haven't learned it yet. We're not going to learn it today either. What I would expect you to do is recursive this business and kind of guesstimate. If you know the 5th year it costs this much, this is pretty close to this guy, right?
Yeah.
So, can you figure out what happens on the 6th year? Yeah. What's f of 6? 21,000 times 0.82 to the 6th power. What do you get?
6,384 and 14 cents.
So when does 7,000 fall?
5.5 years.
Somewhere in between there, right? Somewhere between 5 and 6 years. That is a perfectly acceptable answer for what we're doing right now. Okay?
I think that's. I like multiplied ones there.
based off of the exponent.
But I always like.
We'll get there. We're going to get to play Battleship, too. It's really exciting. It's like one of my favorite movies.
Today?
No.
to find like 1/3 of its value, I just multiply it by 1/3 of that always works.
Nope. Wait, to find 1/3 of its value?
Yeah.
Yeah. Yeah. Does that make sense? Cool. So we're kind of down to the guessing game until we learn how to undo exponents.